Okay, let's start with exercise 5.2. This exercise requires extensive use of MTS, and I'll get into it as we reach those questions, but I'm sure all of you already know that from previous years. Okay, so let's start with this one. The first one does not require MTS, and we can just simply simplify it and then group the like terms together and then get our answer. So we just solve for x, so let's start. X squared plus x times 3 minus 2a minus 6a equals to 0. If I open these brackets up and I distribute x, I get x squared plus 3x minus 2ax minus 6a equals to 0. And now if I group these two terms together and I group these two terms together, then we get this x times x plus 3. And if I try to take, I want to get x plus 3 in both these brackets. So if I take minus 2 out common, I'll get, minus 2a out common, I will get x plus 3, right? Minus 2ax minus 6a. And now I can take x plus 3 out common like I wanted to. X minus 2a, what equals to 0, equals to 0. And now by using the zero product rule, which simply states that if you multiply two numbers together, either the first one equals to 0 or the second term equals to 0, right? So if I consider that this equals to 0, then I can simply say that x minus 2a equals to 0, and I just cancel this out because this is not equal to 0, and I can divide by this, and I get that x equals to 2a. And if I consider that this equals to 0, that means that this is not equal to 0, and I can cancel this, then I get x plus 3 equals to 0, and x equals to minus 3. So now let's just write that down on the top somewhere. So if I just delete this portion once, I can simply say that either my x is equal to minus 3 or my x is equal to 2a, which is our final answer. Let's erase this part as well. Okay, right. Now let's move on to the next question. This question requires MTS. So I'll just quickly revisit the concept here. So what is MTS? So let me just copy down this equation once. 3a squared x squared plus 8abx plus 4b squared equals to 0. So now what MTS means is, first of all, you identify the coefficients. Coefficient of x squared is 3a squared. Coefficient of 8abx is simply 8ab. And here the coefficient is just 4b squared because there's no term of x. And now what MTS rule states is that you multiply this one with this one. So that's 3a squared times 4b squared, which gives us 12a squared b squared. Now you have to somehow break down 8ab in such a way that obviously it remains, once you add those two parts up, it becomes 8ab. And when you multiply those two, you get 12a squared b squared. So now, what are some of the ways that you can achieve 12 by using numbers that add up to 8, right? And if you think of numbers that multiply to 12, you can think of 3 into 4, 12 into 1, and 6 into 2, right? Which out of all these ways adds up to 8? The only one is this one, right? So we have to break up 8abx into 6abx plus 2abx. That way we get 6ab times 2ab, which equals to 12a squared b squared. And we also make sure that our term is not destroyed and it adds up to 8abx. So let's do that. 3a squared x squared plus 6abx plus 2abx plus 4b squared equals to 0. Now, once again, we'll just copy the same process as what we did earlier. You got four terms, group two terms together, take out the common factors, and then use the zero product rule. So from here, I can take out 3ax, and I'll be left with ax plus 2b. And from here, I can take out 2b, but common. I'll be left with ax plus 2b. Now, if I take ax plus 2b out common, I'll be left with 3ax plus 2b. And now I think I'll move this question slightly lower so that we get some more space. right? Okay, we get this equals to 0. And once we use the zero product rule here, I won't show it this time, but we can either case 1 says that ax plus 2b equals to 0. So my x is equal to minus 2b over a. And if I look at case 2, that means that 3ax plus 2b equals to 0. And my x equals to minus 2b by 3a. So now, if we add this both together, our values of x is either equal to minus 2b over a or minus 2b over 3a. Okay, right. I'll just paste this and I delete this for now. Okay, this is our next question here. So, yeah, okay. Now, this is a slightly more complex one because it deals with roots, and we haven't yet ever come across a question which has a root in the middle. So, how do we deal with this? We follow the exact same process and don't need to worry. It's pretty simple and straightforward. So, let's write this down. 6x squared minus root 2x minus 2 equals to 0. Now, I know you may be tempted to square both sides so that you can remove the root and all, but avoid doing that. It's much simpler to just follow the same process and get your answer. So we have to, first of all, we have to get the number to multiply to 6 times minus 2, which is minus 12. Okay? How do we break down root 2 in such a way that it adds up to minus root 2, but at the same time, it also multiplies up to minus 12? Okay. So the way to do it is, so basically you have two terms with root 2, right? Because obviously you will need some combination of either 3 root 2, 2 root 2, and another combination of 4 root 2, 3 root 2, something like that. And when you multiply two root 2's together, you get a 2, right? Now, once you get a 2, you basically need your whole number part of it to multiply up to 6, right? Because you need 2 times 6. So this is the way you should always approach it. If you see a root 2, you know that you have two terms. You need to break this up into two terms, each which have a root 2. When you multiply two root 2's together, you get a 2, right? So now you have to get the remaining whole number part of it to multiply up to 6 so that you can get minus 12 here, right? So how do we do that? Okay. So how do I get two whole numbers that have a root 2 part of it and they together multiply up into 6, and when you subtract them you get minus 1. So we simply do write that as 6x squared minus 3 root 2 plus 2 root 2 x. Okay, there's an x here. Minus 2 equals to 0. Now add these two up, minus 3 root 2 plus 2 root 2 minus root 2, exactly what we wanted. Minus 3 into 2 minus 6, exactly what we wanted. Root 2 to root 2, 2. So minus 6 into 2 minus 12. And this is exactly what you have to do. With practice, you'll get it really easy. So let's simplify this now. So again, over here also, there's even in this step, you have to be really careful because there may be a case where you have to also take a root 2 out common from here. So if you look at this, um, what what can I take out common from here? I can simply just take out 3 common, but okay, so let's try that. Let's try to take a 3 out common here. So if I take 3 out common, 3x out common, so I'll be left with 2x, and I'll be left with minus root 2, right? 6x squared minus 3x times root 2. And over here, if I take a 2 out common, okay, over here, if I just simply again take a 2 out common, I'll be left with root 2 minus 1, root 2x minus 1. But now over here, you will see that the brackets don't match, so you can't take out anything out common. So how do you change this? How do you avoid this? And the answer to this question is you have to take a root 2 out common. So because as you know, 2 is equal to what? Root 2 into root 2, right? So if I just break up 2 into root 2 and root 2, then I can take root 2 out common, right? So how can I do that? If I just, oops, yeah, okay, if I erase this part, And now, if instead of taking 2 out common, if I instead take root 2 out common, then I'll be left with 2x minus root 2. So 2 root 2x minus 2, having the same part inside, you're getting 2x minus root 2 inside the brackets, and outside the brackets, whatever you have is remaining the same, right? So now just take 2x minus root 2 out common, and other bracket is 3x plus root 2. And now using the zero product rule, you can either get x as root 2 by 2 or x as minus root 2 upon 3. Okay, so now before we move on to the next question, I just want to like reiterate what we did in this entire question here first. So first, we had to get two numbers and multiply up to minus 12, right? And we know that we had to break root 2x into two parts, which each have a root 2. And when we know that two root 2's multiply up to 2, that means we require the whole number part of it to multiply up to minus 6. And we did that by breaking it up into minus 3 root 2 plus 2 root 2, and because we know that minus 3 into 2 is minus 6, and our root 2 parts multiply after 2, so we get minus 6 into 2, which is minus 12. And then we factorize by grouping the terms and taking out the common term. And we notice that if we just take whole number parts out common, there may be a part which gets left behind and which does not, which makes it that it's impossible to take something out common. And in such a case, we have to like do some trial and error and find out which part to take out common. Like earlier, I took out 2 out common, but then I realized, okay, wait, I have to take root 2 out common. And then once you get your two brackets, you have to use the zero product rule and get your final answer. Right. So, okay, I think we had another question on this. So let me just paste that here and just delete this for now. Right. So if I just shift this question here. Okay. So now let's solve this one. So, okay, this is a similar question, and let's solve this the same way. So we've got 3 root 2 times x squared minus 5x minus root 2, which equals to 0, right? And now once again, we need what should I multiply up to? 3 root 2 times root 2 is just 2. So we have to multiply it up to minus 6, right? 3, let me just write it down once. 3 root 2 times minus root 2, that's minus 6, right? That's what we to multiply up to. And obviously, this is a simple case, so we got 5x, right? So we know how can we get minus 6 directly? We can just do 3 root 2x squared minus 6x plus x minus root 2 equals to 0, right? Minus 5x multiplies that to minus 6, exactly what he wanted. Okay, now the trickier part comes where we have to take out the right factor out common. Okay, now over here, I'm going to give you another tip. Last time I told you if you have a root in the middle, what you should do, but now you've got roots in the side parts. Okay, in such a case, you see 6x here and you see x here. What's a simpler part to factorize? When you see x, you know you can't take out any root component. If you see 6x, you know that there's a possibility to take out root component. So just simply ignore this part of it first and try to factorize this part of it first. Now, x minus root 2, there are no common factors, right? You can't take out anything out common. It's completely different. So just simply write that as 1 times x minus root 2. Now you know that whatever you do, x minus root 2 should come out common here. So how do we achieve this? So what we could do is obviously we're going to take out x out common. Okay, let's just do some trial and error here. Okay, so if I just take 3x out common here, which is what we would normally do, there was no root here, we would get root 2x minus 2, right? But now, once again, this doesn't work. Let's try it another way. Okay. Now notice we need a root 2 not attached to the x, right? So that means that we have to eliminate the root 2 from the first term. So how do I do that? What if I take 3 root 2 x out common now? 3 root 2 times x out common here. Now I just have x here, which is exactly what I want. And over here, what will I be left with? What I'll be left with? A root 2, right? 3 root 2 times root 2 is just minus 6, which is exactly what we wanted. And we've got our two terms now. So this is exactly how you approach this. Use these couple of tricks which I've told you, and it should not be too difficult, right? Okay. And obviously, if worst comes to worst and you can't find the like terms, then I'll be teaching you the quadratic formula in the later videos, where which you can use those. But it shouldn't be an issue. Trust me, if you practice these, there are like 4 or 5 examples, there are 4 or 5 questions in the exercise as well. You wouldn't get any problems with this. So now if you take x minus root 2 out common, you'll have 3 root 2x plus 1. And you either have with this, you either get x equal to root 2 or x equals to minus 1 over 3 root 2. Now, in such a case, it's always advisable to rationalize the denominator. And I'm sure you remember rationalizing from previous grades. Wherever you see a root in the denominator, you multiply both the numerator and the denominator by the root. So I'll multiply this by root 2 and multiply this also by root 2. You can do that, right? And then we have minus root 2 by 3 root 2 into root 2, 3 times 2, 6. So that's our second root. So let me just erase this part out. Our second root is minus root 2 over 6. Okay, so now we move on to the next question. Okay, before this, that was a question which I had deleted, right? So let's just put that here. Okay, now this question, not at all difficult, but there are lots of places where you can make calculation errors. So you just make sure you do these slowly and don't make any errors. So over here, what do we have? We had to solve for x. This doesn't look like it's in quadratic form, right? You don't see any x squares. But when you simplify and take an LCM, then you will see you'll get a quadratic equation in the form of ax squared plus bx plus c equals to 0. And then you can solve it by factorization. Okay. So let's try to get it to this stage. So how will you do that? We need to get we need to remove the denominator from here, right? So for that, our LCM is for the entire thing would be x minus 2 times x minus 4, right? And for this, we have to multiply this first term by x minus 4. So if I can write this as x minus 1 times x minus 4 plus x minus 3 times multiply this by x minus 2, right? And we need a denominator here. Oops. Second. Yeah. Okay. Yeah. And on the denominator, we have x minus 2 times x minus 4. And this is equal to 10 by 3. Right? Now, you can just cross multiply here. So we can just take 3 this side, this side, and we can get 3 times x minus 1 times x minus 4 plus x minus 3 times x minus 2, which equals to 10 times x minus 2 times x minus 4. Okay. Now we've eliminated all the denominators from this question, and now we shouldn't have any major problems, right? So let's now just simplify this. And if we simplify this, we will get x times x squared minus 4x minus x plus 4 plus x squared minus 2x minus 3x plus 6. And I'm not writing the LHS because I just want to first, or the RHS because I just want to first simplify the LHS. So if I do that, I get 3 times x squared, 2x squared. So you can just cancel this out from here so you don't get confused. Minus 4x, minus 5x, minus 7x, minus 10x, right? 5x minus 5x. So you can cross out all these terms from here. Plus 10 and is equal to, now if I simplify this, I have 10 times x squared minus 4x minus 2x plus 8, right? We just move this question lower. Right. Okay. So now, once you do this, further simplify this, so you will get what? 6x squared minus 30x plus 30 is equal to, if I just simplify this as well, This is what? Minus 6x, right? So let me just write this as minus 6x. Oops. Yeah. Okay. So now if I simplify this side, we have 10x squared minus 60x plus 80, right? And now let's get this in the form of ax squared plus bx plus c equals 0. So let's take everything to the right hand side and make the LHS 0. So that means we have 10 minus 6, 4x squared. Cancel this out from here so we don't get confused. Minus 60x plus 30x. So that's minus 30x. And 80 minus 30 is plus 50 equals to 0. Now we can divide this entire thing by 2. So we can get a slightly simpler quadratic. 2x squared minus 15x plus 25 equals 0. And now we have 50, right? 2 into 25 is 50. We'll break down minus 15 in such a way. This is also extremely simple. I think all of you will get it immediately. Minus 10x minus 5x plus 25 equals to 0, right? Minus 50 minus 15. So 2x out common. X minus 5 minus 5 out common. X minus 5. Okay. Now, if we, let me just move this question down a bit lower once again. Right. Okay. Now, if we take x minus 5 out common, get 2x minus 5 here, and zero product rule, you get x equal to either 5 or 5 by 2. Okay. Simple question. Just make sure you don't make any errors in the calculation because it's pretty extensive. Okay. Now, I think before this question, there was another question which I had deleted, right? This is an extremely interesting question. Please just like listen to this very carefully. It's not a very similar question. It's nothing like you've ever done before. And this is an extremely important concept. And this will be tested on in your first sem examinations, pre-boards, maybe even your boards. So what do you see here? You see an under root sign, and we see 13 minus x written here, right? Okay. So how will we solve this? And obviously, we don't see any quadratic here. We see a root sign here. There's nothing much we can do. So we have to just square both sides. That's the first step, which is expected, right? If I simplify this, 13 square is 169. And on a side note, although you don't need to memorize these squares, it's always really, really good if you know all your squares up till 25, because that saves a lot of time on calculations. Plus x squared minus 26x. And over here we have 2x plus 9. Right? Let's get this in the form of ax squared plus bx plus c. So we have x squared minus 26x minus 2x minus 28x, right? And just like minus 28x plus 160 here, right? So 169 minus 10, which is 160 equals to 0. There we go. And now 160, how will we break it up in such a way? So it's simple. Again, directly just see it 20 times 8, x squared minus 20x minus 8x plus 160 is equal to 0. And we can once again just group the terms together. Minus 8 out common, x minus 20 equals to 0. So we have x minus 8 times x minus 20 equals to 0. And you can get x as either 8 or 20. But please don't stop here because this answer is wrong. Now let's see why it is wrong. So we've been told that a root of 2x plus 9. Okay. Let me just, before I explain anything, just explain what this square root sign means. If I have a root of x, can x be negative? Okay. Can root of x ever be negative? Okay. Now to answer both these questions, both of these questions are wrong. You can never have, if you have a root of x, x can never be negative, and a root of x can never give you a negative answer. So a root always takes a positive number and it always returns another positive number. So, okay, now if we try to input the value of x, so what was that thing? It was the root of 2x plus 9 equals to 13 minus x, right? And we got our values of x as either 8 or 20. So let's just try putting 8 into this, okay? So we have 8 2s are 16 plus 9 root 25 equals to 13 minus 8. So 5 equals to minus 8 is also 5. So this one stands. But now if let's try putting 20 inside of this. So I have 2 times 20, which is 40. So we got root 49 equals to 13 minus 20 equals to minus 7. But as I said before, root of a number can only give a positive number. You guys may be wondering, minus 7 whole square equals to 49. So why can't root of 49 equal to minus 7? The answer to this question is wherever you see a root sign, automatically assume that the root of this will only return the positive root. However, if you are told that x square equals to 49, then x can also be equal to minus 7. So how do you distinguish between the two? Whenever you see x square is equal to 49, what you do is you do x is equal to plus minus the root of 49. The root of 49 will give you 7, so you'll take 7 and minus 7. This is a Just always keep this in mind. This will be used in high classes as well. Okay. So now that you gotten this out of the way, we have to reject 20 from here because 20 makes the answer incorrect. So our only value of x is 8. Okay. And there's, I think, one last question left. Okay. This is not an extremely tricky question, and I'm sure you guys will solve this correctly. But if one root of the quadratic equation is this, then find the value of k, also find the other root. We did a very similar question in the first exercise, so let's just do the same way. If we know one of the roots is 2, we can just replace x with 2 in all the cases. So that's 2 times x is 2, so 2 square, plus k times 2 minus 6 equals to 0. So that's 2 times 4 plus 2k minus 6 equals to 0. 8 plus 2k minus 6 equals to 0. And your k comes as minus 1, right? 2 minus 2, yeah, k is equal to minus 1. And we'd also find the other root. Okay, so now that we've got k equals to minus 1, what is our quadratic? We have 2x squared, k is equal to minus 1, right? So it's minus 1 times x minus 6 equals to 0. Now we're to solve this quadratic. Okay, so let's solve this now. Again, 12, how do you get 12? 12 equals to 6 times 2, 3 times 4. And by now, you should just, moment you see only 1, you should always know it's just 4 times 3 only. So it's 2x squared minus 4x plus 3x minus 6 equals to 0, right? Minus 12 minus 1. And you can write this as 2x times x minus 2 plus 3 times x minus 2, 0. So we have 2x plus 3 times x minus 2 equals to 0. So now your roots of this are x equals to 2, comma minus 3 by 2. Right? And they already told us that one of the roots of the equation is 2. So I was just checking if we sorted correctly by that. So therefore, our other root is equal to minus 3 by 2. Right? Okay. With this, this exercise comes to an end. And now we'll be moving on to exercise 5.3.